So here I'm going to continue on with this data set example that we have. Again, this is not the same exact data set we're working with in this module lab activity, but this is a good example. And so let me share my screen. We'll continue on. And again, here you can see I rearranged what I was working on here off to the side a little bit. As you remember, in the last video, I just created that percentage of people who chose bicycling as their preferred mode of transportation, right? It was 40.7%. Here, what I did is I put 1, 2, 3 representing each of the 3 questions in that each of the 3 options for that first question. So 1 is, and let's go back to that dictionary and take a look again, right? Here they are. So this first question for preferred mode of transportation: 1, bicycling; 2, driving; 3, public transportation. So I put those 3 numbers, and then I put the total after we sorted that column and were able to highlight each number and look at the total. I put that total under each number, right? So for bicycling, it's a total of 121. And again, I'm going to create an equation to get that percentage again. So equals, 297 is the total, right? So I'm going to hit this right here, divided by 121 total people choosing bicycling. But I'm going to go a step further. I'm going to put a parentheses around that. And I'm going to multiply that times 100 to automatically give us that percentage, so we don't have to, in our head, move that percentage point over. Actually, that's wrong. As you can see, yeah, I switched the numerator and denominator. So we want 297 divided by 121. Oh, I just did it again. Bear with me here. Other way around. $121 divided by 297. That gives us the 48.74. Whoops. And so we'll do the same thing over here. Equals sign, parentheses, 91 total people chose driving as the preferred mode of transportation, divided by 297 total respondents, closed parentheses, times 100, enter. That gives us 30.6%. And the same thing over here, equals sign, parentheses, 85 total people chose, what was the third one again? Let's look at the dictionary. Public transportation again, bus, trains, subways, etc. as their preferred mode. Let's do that again. 85. I'm not sure why it's coming out that way. Let's do that again. Let's start over here. Equals sign, parentheses, 85 divided by 297 total respondents, times 100 to get that percentage. And there we go. So interestingly, public transportation was the lowest, perhaps suggesting to us that SEPTA needs a little bit of help. They might be stuck in the past. I'm not bitter. Anyway, and so we've got our total percentages here. And now what we want to do, well, what we could do firstly is just to double check ourselves and add these up, right? So 121 plus 91 plus 85 should total 297, and 40.74 plus 30.64 plus 28.62 should equal 100%, right? If all of these are sort of broken down by percentage, they should add up to 100, and they do, and so we're correct here, but that's a good way to double check yourself. So what we want to do next is perhaps make a histogram. And so if we just highlight these 3 items right here, go to the Insert tab, and if you're new to Excel, again, it's a lot of bells and whistles to work with here. Data scientists often complain about Excel. I myself have complained in the past about Excel. It can be a little buggy, especially when you've got huge data sets that you're working with. But I gotta say, at the same time, it is kind of cool, all the things you can do with Excel. And it's your friend if you're working with math, with statistics and data, and you do want to be familiar with it. It can be cool, really. It can be a powerful tool. I remember being skeptical hearing that when I was in college and learning this stuff, but you know, it really is cool. So please keep an open mind. Anyway, let's go to histograms. Right here, this little icon right here, these bars. So a histogram is essentially just one of those graphs that include those bars that are next to each other. And you click on this, and you can go ahead and play around with what you want to select. You can do fancy things, 3D columns. Data scientists and data visualizers usually recommend to you to you know, try to stay away from all the super excessive fancy stuff with the 3D graphs and the you know, frilly graphics. That can be distracting if you really want to get a nice, clean representation of your data across. So do be, I mean, you know, it can look cool, it can be fun, but just be cautious with that stuff in terms of when you want to think about good visualization. But here we go. We'll just do this. I'm going to do this just for the purpose of the example. And so you can see it's represented here. You can move this around on your Excel page. And so you can see 1, 2, 3, each of these represents the different options people selected for this question about commuting. And you can see that, you know, besides walking, bicycling had the greatest overall number. And the next one was driving. Yeah, so number 2, driving, had the second greatest, and you know, not far behind was public transportation. It's just cool, you know, you can, it's one thing to see the numbers represented. It's another thing to see those numbers converted into these bars on this histogram. It does help you to really compare relatively. You can compare each thing relative to the other in a very visual way that can be really helpful. And so it's a powerful tool. I hope you find this helpful.